Today I want to talk about transformations. And this is the worksheet that you have that you had to download. And basically what we're talking about is any function. It doesn't matter what the function looks like, whether that function be absolute value, whether that function be quadratic, whether that function be linear, whether it be cubic, any of those functions that we talked about on yesterday. We can transform any function using these things. And so that's why we use this notation of y equals f of x. And so this really should say that the variable that we're adding is greater than 0. That means that a, b, c, or d, these are the numbers that we're going to add to our functions, are greater than 0. And so that means that they're all positive, okay? We're all talking about positive numbers. And so when y equals f of x, that's our original graph. When we do f of x minus c or f of x plus c, this is inside the graph. And so we want to say that this is inside that we're adding, and that is with x. So when we do the change is inside with x, that means it moves in the x direction. And so when it moves in the x direction, that means that it has to move left or right. So we know that these are going to move left or right, these two, okay? And so the left or right is a little bit different than what we think, because you say x minus c and I think, well, the negative direction is really to the left, but it's opposite. So we do the opposite on the inside. And so what you think is negative would be left is actually to the right. And then adding a positive number is usually you think that's to the right, but it's really shifting to the left. And so if we were to say, let's say our original graph is the square root graph. So this graph would now shift to the right, and this graph would shift to the left, okay? So f of x minus d and plus d, this is outside. Let's see if I can get on the screen here. Outside. And when I say outside the function, I'm talking about outside whatever f of x is. And remember, f of x is another way to write y. So we say outside with y. And so that means that this moves in the y direction. And remember, your y direction goes up or down. So these two right here are going to move up or down. And because they're in the y direction, it's the same on the outside. So negative in the y direction is down, and positive in the y direction is up. And so if we were looking at this graph, this would go down, and this one would go up, okay? Now these next couple are really weird. And it's really, we won't do a whole lot with them, but there's just a few things that we want to talk about with them. And these transformations really, I'm not going to be that concerned with them, but just so you know that if you multiply a number outside the function, in front of the function, outside of the function, that basically this is a vertical, okay? So this moves the graph vertically. Okay? And if we put a number inside with the x, this moves the graph or changes the graph horizontally. Now, the thing about these is that these are so similar that it's really weird, okay? When you multiply a number a times f of x, when you're talking about this number out front, we say that we multiply a times f of x. A is greater than 1. This is a stretch vertically, okay? And so if this is a stretch, then this would be considered a compression. And normally it would just look like compression. Helps if I could spell. It would still just be a, but then it would show this as a fraction. So that's why they wrote this as 1 over a. And these are in reverse. So if it's inside with x, the compression is if it's not a fraction, and the stretch is if it is a fraction, okay? Now, these are really weird when I'm drawing them. And I'm going to do a quadratic graph for this. So if I stretch the graph vertically, okay, so here's my regular x squared graph. If I stretch the graph vertically, I pull it up and it makes it more narrow, okay? It makes it narrow. And if I stretch the graph, if I compress the graph vertically, it's like I push down on it, and so it makes it wider. What happens to this graph in reverse is the compression horizontally is like I'm pulling the graph horizontally, so this makes it wider. And when I stretch it horizontally, this makes it narrow. That's why I don't like these. They make sense, but they don't really. So I don't really like to go over those, but I have to give them to you so you can kind of sort of look at them. Now, these are a little bit better because these are reflections. All three of these, when you have a negative value, you always know that the graph is going to reflect, okay? It's going to mirror. And so let's go ahead and write that these are going to reflect. All of these are going to reflect because they all have negatives. So then you have to ask yourself, how does it reflect? So this is a negative y, right? So if you look at your xy axis, so if I have positive y and negative y, what does it reflect over? Well, it reflects here, which is the x-axis. And this is a negative x, right? So if I do it again, if I have a positive x and a negative x, what does it reflect over? Well, it reflects over the y-axis. And this one has a negative y, negative x. And so what this does is it flips and then it flips again. And so it actually reflects across the origin, okay? So what happens is if it's up here, it moves down here, okay? So a reflection across the x-axis, so if we go back to our square root graph, a reflection across the x-axis would look like this, and a reflection across the y-axis would look like this. A reflection across the origin would look like this. And those are your notes for today. You need to make sure that you do the transformations worksheet that goes along with this assignment, and then take notes, make a copy of your notes and your worksheets for today.